Okay, example 2 says condense the following logarithmic expression using the properties. What does it mean to condense something? To make it smaller, right? All right, so look at A. What's going on here? Well, we got subtraction, right? And we can combine them if they're being subtracted by doing what? By dividing. There's only one problem. It's not log minus a log, is it? It's log minus 2 times a log. So what am I going to do with that 2? Yeah, remember? If I don't need it there, then because it's being multiplied times that log, I can move it back as the exponent. So this is really the natural log of x to the 5th minus the natural log of x times y and then squared. All right, so what can we do now? Yeah, now I can go ahead and divide them. So when you divide them, you write the natural log one time, and it's the first divided by the second. Now I can simplify, though, what's in that fraction, because I have an x on top and an x on bottom, don't I? But that x on bottom is trapped inside with that y because of the squared. So what can I do with that square? Yeah, I can give it, because it's being multiplied, I can give it to both of these. Or, remember, xy squared means xy times xy. Either way you want to look at it. But you'll get natural log of x to the 5th over x squared y squared. And now I can simplify that. So I still have my natural log. What's x to the 5th divided by x squared? X to the 3rd. And is that going to go on top or bottom? Top. That's where the 5 is at. The larger exponent. And then on bottom, we still have that y squared. All right, B. What's going on there? Yeah, they're being subtracted, so we got log minus a log, so we can go ahead and combine them how? Division. Okay, so you're going to write out the word log once. What goes on top? The 5, because it's first, over x. Can I do anything else there? Nope, so that's it.
The 5 is good.
All right, so on number 3, you're telling me the first thing that we did is, how did you get this answer? Yeah, you move the coefficients there to become the exponents. Okay, now what are we going to do?
Distribute the exponents.
Okay, so distribute the exponents. So we got the natural log of x cubed cubed, and then y cubed, plus the natural log of y squared and z squared squared. And it's a little confusing with all the parentheses. But when I go through this, I got the natural log. What is x cubed cubed? X to the, what do you do when it's power to a power? Multiply the powers. 3 times 3 is 9. And then we got our y cubed. Plus the natural log, we got y squared. And what is z squared squared? Multiply them, so you get 4. Excuse me, now what can we do?
Now I can set them over each other.
All right, well, they're being what? Added or subtracted?
Added.
Added, and what do we do when they're being added? We multiply. So we got the natural log, I'm going to do a big parenthesis here, of my first term times my second one.
Is it only when we put them over each other when we subtract?
Right, you only divide when you subtract. You multiply, you multiply when you're adding. All right, so everything inside here is being multiplied, correct? So I'm going to lose some of those parentheses there. So I have x to the 9th times y cubed times y squared times z to the 4th. Looks a little nicer. And can I do anything else? Yeah, your y's can be combined. So you have your natural log. You have x to the 9th. What is y cubed times y squared? What do you do with exponents when you're multiplying? You add them. So you get y to the, and then we have our z to the 4th still. And there's our condensed form.